Welcome to the AI First Business Podcast with Tina Yazdi, where we show you how teams, companies, and leaders are turning AI hype into ROI. Welcome, Wes. How are you doing today?
I'm great. Thanks for having me, Tina.
Yeah, thanks for joining. I'm going to be honest with you. This is one of the episodes I'm most excited to record because this is giving us an insight to, your words, not mine, the 90% of the challenge with bringing AI to life this year and in the coming years that even I didn't really know too much about. Just as a quick intro, Wes is currently the CEO and chairman of Applied Digital. And prior to that, he also founded 272 Capital and is an investment advisor focused on technology, hardware, software, and service companies. And it sounds like you sold that to B. Riley Financial.
That's
Is that
right.
correct? Nice. And Applied Digital is also listed on Nasdaq. And Wes not only is a veteran investor, but he knows deep information that I hope we can dig into today about what it's going to take for data infrastructure to support AI technology, some of the gaps and the magnitude of the gaps, and as well as a couple of other really important topics like the energy required to power all of this. Wes, did you want to say a few words about yourself and maybe Applied Digital before we dig in?
Sure. So you hit a lot of it, and appreciate that intro. So I've been career tech investor. So I've made mostly in what I call hard tech. So a lot of like semiconductor and tech hardware, some software. And back in late 2020, I had the idea around really from an investment angle on, we got our start in crypto, and the investment angle on crypto at that time was the way you could quote unquote, invest in crypto is do anything but Bitcoin and deploy a lot of GPUs, mostly in Ethereum, but there were other, proof of work networks that you could kind of aim your GPU compute at those networks and validate transactions, right? Be a miner on those networks. And so the idea was, large scale deployment of GPUs. That was the original idea of the company. We had partnered with a company called Sparkpool out of China. They were at the time the largest Ethereum pool in the world. They had about 25% of all the Ethereum hash going through their pool. That was really where we started, and we raised some money, and this is the beginning of Applied. We raised some money. We bought, a significant number of GPUs. They were all going to be deployed in China, in the Sichuan province in China. We did our round in April of 21, and right before we deployed those GPUs at the end of May, it was when China cracked down on crypto. So it was a complete crackdown, and so we were sitting there waiting, kind of going, okay, what do we do? Our GPUs were sitting in a warehouse in Shenzhen, ready to ship. Do we ship them, or because China had kind of done this before, or is this real this time, or do we not? By the end of that happened on a Friday. By the end of the weekend, I realized we needed to ship those to the U.S. We did. We deployed them in a different facility, upstate New York, and what happened subsequently was we had the opportunity to build out Bitcoin data centers. And so I'd already started to assemble a team, but we assembled a team. There was a really, shallow talent pool here in the US because I think less than 5% of Bitcoin mining was going on in the US at this time, but 70+% was going on in China, and those all needed to move somewhere. And then so I found a guy who was really good at power. We had a guy who had brought the first, mining facility on in the U.S. in a company called Mineco that turned into Core Scientific. But we assembled a team. We found a site, through our power guy, and we broke ground on that site in North Dakota in September of 21. And that site was operational by January of 22. So it was really fast, about 4 months to get that going, and then fully up a few months after that. And then since then, we built out a total of 500 megawatts over 24 months of these types of sites. And then about 18 months ago, a little longer than that at this point, I was looking around at what else can be done with these sites. And we started to build a very different style of high performance computing data center, very high power density. And this is what we'll spend a lot of time on today, is this digital infrastructure. And so we started designing that. We started building it in 22. We have that up, in 23, some of the capacity running. We also put in place software pieces we needed to do a cloud service. That was in the fall of last year. So it's, sorry, I'm getting confused now because we're just barely into the new year. So that was in the fall of 22. Yeah. That was in the fall of 22. So we started building the data center in 22, and then October of 22, we put a partnership in place on software to run a cloud service. And at the time, the only reason we did that was because we thought we would have to be our own first customer in our data center, because it was a really new style of high power density data center. And then kind of fast forward to where we are now. So December of 23 or 22, sorry, ChatGPT is introduced. And then in March of 23, the H100 was introduced by NVIDIA. It was the latest data center class, highest power GPU they'd ever introduced to the market. At this point, you had a lot of generative AI companies out there, and then ChatGPT was the big breakthrough on Gen.AI. We saw a rush of demand, and the switch really flipped for us kind of mid-April, late April of 23, where we started seeing all this demand. And we were still out kind of shopping this data center capacity when we landed our first customer in Character AI, a big Gen AI customer that wanted thousands of H100 GPUs deployed, but they just wanted a service. So we launched our cloud service. And really where we've taken the company now is we're building data centers, HPC infrastructure, what I call next generation digital infrastructure. And we also offer a cloud service. Plus, we have a large data center business on Bitcoin specifically. So we have all three of these things. But what has been the big transformation, over the last year is the way digital infrastructure, has to be built. And we just happen to kind of be building this before it was obvious of how it needed to be built. It was kind of more speculative for us. And I wasn't expecting, the Gen AI boom by any means, but we kind of got lucky in that. But that's the background of the company, kind of how we came into being and the growth we've had. But it's been a pretty crazy couple of years for us, but especially, the last 9 months, just what we've seen, the changes in the market, the requirements, on the infrastructure side. And we can delve into, the big requirements there, but it's been a fun time. That's for sure.
Oh, we
That's
will.
for sure.
Yeah. It sounds like there's a lot of right place at the right time doing the
Yeah.
right things, but it sounds like you also seize the opportunity as soon as you
Yep.
saw it, maybe earlier than others. Just to give some listeners a chance to catch up with some of these terms and some of these kind of like infrastructure definitions in your worlds, can we just set some ground level definitions? Can you maybe take a minute to walk the layman through what are some of the differences between traditional data centers, hyperscalers, high density energy? I think, sorry if I misunderstood that,
High power density. Yep.
and what AI GPU cloud services is referring to. And I also saw on Applied Digital's pages this term
Yep.
supercomputing as a service, which seems like it's poised to take over what SaaS means to some
Yep.
people, at least. Can you just give like a really brief 101 on what all these things are so we can continue the rest of the
Sure.
conversation with a bit of context?
Sure.
Thank you.
So, the last 20 plus years of data center build out have been really it's been communications driven. I call it comms driven, right? It's been very comms driven, ultra low latency, high bandwidth, because think about the apps that have, really developed over the last, 20 years, really 10 years. It's all video driven, right? Almost everything we use, all the consumption of what we do, everything that's on your phone or on your TV at home or us sitting here, doing this podcast on video, all of it is very, very video driven. And so what video requires is it doesn't require a huge amount of processing power. It requires very low latency connectivity to the data center. So that means you need, sub 10 milliseconds between where you're using it and the data center, call it round trip or sub 20 millisecond round trips. Because if latency was high, this experience would be bad for all of us, right? It's been very driven around latency and not around compute. And so that's how, that you've had.
And sorry, I'm just breaking this down just in case maybe someone doesn't use the term high latency, low
Sure.
latency. Can you just define quickly, like what's the difference between these two?
So low latency means almost instantaneous. So when you speak in terms of latency, generally to be in data center regions, right, so that's why there's a lot of data centers deployed just outside of New York City or outside of LA, or Dallas is a big region, right? Big population centers, because you want the content very close to the end user. And so if you're using Netflix, for example, or you're streaming TikTok or whatever it is you're using on video, if it's very slow, and let's think of it like buffering, and I'm old enough for
Mhm.
this, and maybe a lot of people aren't, but when you started using the internet, 15, 20 plus years ago, if you wanted to watch a video, for example, right, there's a bandwidth and a latency issue, right? So bandwidth was a problem, and then latency becomes a problem when you have plenty of bandwidth. So when we used to all do dial-up and you wanted to watch a video and you clicked on a video and then you went and made yourself something to
Mhm.
eat, right, or whatever, because it was going to be buffering for 20 minutes before it it even played. Depending on the length of the video, it might be much longer than that. So, what the world has evolved into is high bandwidth, last mile high bandwidth, but then the data centers, you need low latency because if you and I were talking on this video app, normally you tell people Zooms, right? This isn't Zoom, but it's something similar. There was a huge amount of latency. It would take you time. Like if you look for like TV news reporters, right? When someone's coming in by satellite and they talk to someone and it takes like
Like,
yeah, it's like 10 seconds for them to
yeah.
hear it and then it goes back. So that's the latency aspect and like kind of the world we live in now, like latency is just not tolerable by anyone. It used to be, like I said, you would click and you would buffer and you'd go make something to eat and you'd come back to maybe watch your video. And now like people are throwing the remote if the Netflix doesn't start in like 2 seconds after they click the button. So we've built our world around low latency, and that's all the video streaming apps that we have, and mission critical apps that we need as well. Need to have ultra low latency and very high uptimes. And so that's the world that's been built. And so you have data centers that go for enterprise, and then you go all the way to hyperscaler. But the vast majority of data centers that are built for this application are configured in what we would call low power density. So you have the latency aspect is one, but then they're configured in low power density because they don't require a lot of computing. So most of these data centers deliver, and if people imagine a data center, right? It's just rows of compute and they're stacked, it's blade servers stacked on top of each other. And you might get 20, 30, 40 of these in a single rack of computing, right? Network switch on the top. And, an entire rack of servers in the traditional data centers, they deliver around 7.5 kilowatts of power to that rack of servers. And typically that rack of servers or cabinet of servers will only use about 5 kilowatts of the power that is needed, maybe even less than that. So that's a traditional data center, 7 kilowatts of power for an entire rack of compute of web servers. And then when you go to AI with the GPU servers, to just put that in comparison, a single NVIDIA H100 server that has 8 cards in the server and HGX DGX, which is the InfiniBand configuration, a single server takes 10.2 kilowatts. Compare that to an entire rack using 5 kilowatts in a traditional data center. And not only does the single server need that, but you need multiple servers in the same rack. You need them all close together. So this is the high power density, right? So you need it very dense. You need them all close together. And the reason you need them close together is because you have a special type of networking, optical networking called InfiniBand, and you can also do it in an Ethernet configuration called Rocky. But most of our clients are looking for InfiniBand, and then kind of the magic number on InfiniBand to put all of these GPUs on the same cluster is 30 meters apart. They can be 30 meters apart.
Sorry, they need to be, or they should maximum be that far apart?
They need to be, I should have said it, less than 30 meters apart. That's your max. For these to work, back to the Supercomputing-as-a-Service. So these work as supercomputers if they're all interconnected with InfiniBand, and then they're extremely powerful compute that is needed for model training, and in some instances for inference, but really for training AI models, these, the ChatGPT, when you talk about GPT, when you do the model training, so came out with at GPT-3, and then we went 3.5 and then 4 and then 4.5. So the training of the model is what gets it to the next level, right? It makes it better, training more data into the model. And so you need these close together. Traditional data centers can't even handle a single NVIDIA H100 server in their entire rack, the way they're configured right now.
Wow.
Much less can they put, 4, 5, 6 of these in a rack and then put many of the racks close together. So you have this high power density issue. It's becoming really apparent in the market, and it's going to become even more so in 2024. And so that's what we're doing. We're building very high power density data centers that are built specifically for these types of workloads. Now, the thing for most of these, especially on the training side, they do not require low latency. They're much more tolerant to higher latency because it's just moving large amounts of data inside the data center, and then the GPUs will crunch to train this model for days, weeks, months, and then moving the trained model, a big file back out, and then placing it typically in a lower latency setting for inference. And inference is you train the model and then you upload the model, and then inference is when you use ChatGPT, it's doing inference, right? And it's interacting with you and it's spitting out the answers that you want. And that's a lot of the different models. So you don't need as low latency, especially for the training aspect, but you do need extremely high power density, and we need a lot of it, right? If you look at the NVIDIA forecasts and the forecasts in the market, right, if you're going to ship, over the next 12 or 18 months, 2 million H100 class GPUs, you need, over 4 gigawatts of power just at IT load, which translates into 6 gigawatts of roughly total power just to bring those online. And that's where we get into this
Yeah.
being the bottleneck. That's kind of the one-on-one is you're really moving from traditional data centers, which that market, by the way, is still growing, right? It's still a growth market. So this isn't a
Mhm.
replacement. It's in addition to you need this high power density configuration, and it's hard to retrofit, by the way. It's hard to retrofit current data centers. It's better, in my opinion, to do greenfield new builds.
You said that the current low latency data centers that support things like video can't support this. One is the retrofitting piece. To clarify, is this because they, one, don't have space, and two, they just don't have the energy load
It's
capabilities to power this? Or it sounds like maybe it's a bit of
They would
both.
have to reconfigure two things. They'd have to reconfigure the power density. And typically, in most of these, you can't just snap your fingers and get more power into the data center. So if you had a data center that's commissioned for 50 megawatts and it's sitting in downtown Dallas, or not downtown, but in the
Hmm.
Dallas metro, and you all of a sudden want to reconfigure that with the new power density, you're typically
Hmm.
reconfiguring to like a 10 to 1 on the power density. And if you can't bring more power into the building, you're going to have 90% of your floor space open because you don't have the power, even though you want to reconfigure. So you need to do that. And getting the additional power is a big issue. But then on top of that, cooling becomes an issue. So when you use a lot of electricity and computing uses a lot of electricity, it creates a lot of heat. And so these typically aren't built for the type of cooling you would need for these high power density workloads. So it makes it much harder.
Just next up, I had a few additional. I'd love to dig into kind of an overview of the market and where it's headed. And as part of that, dig into like the situation with chip supply, energy, and geographical
Yep.
limitations. And then maybe after that, we can transition a little bit more to the supercomputing as a service and onboarding customers that maybe don't have as much context. Some of the customers that you're already working with already ahead of the
Yep.
game. So kind of like digging back into the, thank you for setting the scene on the transition from traditional to the type of infrastructure AI needs to compute the things that it computes. How are you seeing the marketplace in data centers, whether it's existing data centers trying to like transition to capture this demand or like new ones entering the market? Is this an easy market to break into if you have the resources? Is there a lot of competition, or is it more like anyone who can get into it, like can get into it right now just because there's such high demand?
It takes a lot of expertise in this market, and I've
Mhm.
become an expert. But what I have done is surround myself with people who know exactly what they're doing in this market. So it takes several things. You need to find the power, right, on the data center. You need to select the right site. It needs to have a lot of different, things at that site to make it a viable option. So you need to have the abundance of power is available at a location is kind of number one for us. But then you need to check a lot of other boxes at that site. It can't just be anywhere. One of the biggest boxes to
Mhm.
check is fiber connectivity to the site, which is a bigger issue around. We have
Mhm.
Bitcoin data center business, and now we're building in.
Oh, that's
Yeah,
still
yeah,
running at
yeah,
the
yeah,
moment.
and a high
Got it.
performance compute business, but not all of our Bitcoin data center sites work for HPC sites. So our sites in North Dakota both work,
Mhm.
but our one in Texas doesn't work because it doesn't have the fiber infrastructure that is necessary nearby. You don't just need fiber, you need redundant fiber, meaning multiple different providers. So you have to find this. Then you have to, design a facility. We have a kind of our own design that we've been working on for the last couple of years with refinements. So you need to know how to design the facility, and then you need to be able to build the facility, and then you need the capital that goes into it because these are very expensive. So we're in the middle of what it's kind of been my vision is the facility we're building in Ellendale, North Dakota now is going to be 100 megawatts, same building, and it is what I call the AI brain data
Mhm.
center. It's configured and built in such a way, or will be built in such a way, but designed in a way that you could actually put all of the GPUs inside of the building on the same compute cluster. So you could get roughly 70,000 H100 class GPUs on the same cluster. So that would be, far and away
Mhm.
the largest supercomputer in the world if you did that. Unlikely that we'll have a customer that wants all of them in the same cluster, but it's designed that way and it's done multi levels. it's not an easy business to break into. There are other people doing it, right? There's people who've been building data centers. It's been a great business for a very long time. You have, Equinix is the public company that's the leader in traditional data center. I haven't really seen them come into this market. I'm sure that they have plans and they'll be trying to come into this market. It's just such a big growth market that I think a lot of people will. So there's a lot of people trying to get into it. The biggest gating factor right now is availability of power and availability of power that will come online over the next 24 months. And so, we have 400 megawatts of power that can come online over the next 24 months. We're sitting in a really good place for that, but that's the biggest issue right now is the power availability in the near term.
Yeah, actually, let's maybe transition it into energy a bit deeper. Because in the last really interesting, and I learned a lot in our last conversation, point that you made is the competition of electricity, which is already kind of limited in availability in many geographies, but the competition against electrification of vehicles, hydrogen manufacturing, et cetera. Can you maybe talk a little bit about how big of a leap in gigawatts you foresee in the next like 2 to 3 years? And in addition to that, like how do these other changes in society and infrastructure outside of computing impact
So
that?
so let's just talk about the AI infrastructure. I talked a little bit about the power consumption, and then I said just the NVIDIA shipments, right, is going to need over 4 gigawatts of IT capacity. And then when I say 4 gigawatts of IT capacity, it's more like 4.5. Then you need to multiply that by typically about 1.35 because there's additional electricity needed for cooling and for mechanical inside the data center. There's the IT load, and then there's everything else that
Mhm.
supports it. So you're looking, over the next, I would say, 12 to 18 months, 6 gigawatts of power that needs to come online, mostly just for NVIDIA, right? I'm not counting like AMD or Intel or any of the other players in the market.
And sorry if this is a really silly question. When you say just for NVIDIA, is that for them to produce the
No, no,
chips or to
that's
support chips coming
support them
online
coming online.
in
Support them
infrastructure?
coming online.
Okay.
And
And this is like for all the deployed NVIDIA chips, like the 550,000 that were deployed
yeah,
last year.
and
And
what I'm
okay.
really looking, forward is what is NVIDIA expected to ship for the next, 12 to 18 months. And when I look at that, that's what I'm talking about with that additional kind of 6 gigawatts of power. And so let's put that in perspective of the North American data center market is roughly 22 gigawatts. So that's a big leap in a single year, and it likely doesn't stop. I've seen forecasts as much.
This is for the entire data infrastructure
Correct.
market in the whole of the United
Correct.
States.
22.
Okay.
And I'm talking about another six that, in 12 to 18 months. And then through 2030, I've seen forecasts as high as, close to 40 gigawatts of power that needs to be added in data center capacity. It's a big number, right? We're in 24, that's 6 years away. So even if it's 30, right, you're trying to recreate what was created in the last 20 years in 7 or 6 years, so or even do more than that.
A lot.
And you'll continue to build for those traditional applications as well. Those aren't going away. This
Mhm. And they're growing as
does
well.
not replace that. So it's a massive amount of power that needs to come online over the next 5 or 6 years. But I think the biggest challenge is the next 24 months because this whole thing caught, I would say the data center industry kind of really off guard. And I had a lot of conversations, especially on our cloud product, because we do use some third party providers where people are just trying to figure out what's going on. Well, what's going on is, people think about I think most people think about AI in many ways being like software 3.0. And it's just in one small way it is, but it's just not. It's very different in that when you look at these companies, the ones that we're servicing, they have millions and millions of users and they have, sub 50 employees typically, right? It's not an army of programmers. It's all compute driven. And so historically when you did software, you'd have a lot of programmers and then you'd load it up on really standard hardware and it didn't consume a lot of power and it would run, whatever application you're looking for. And now on the AI side, it's really compute driven. It requires the infrastructure to drive the AI. It's very, programmer light, I would call it, and very compute intensive. And so it's just a very different dynamic in the market. But so you have this AI build out that everyone's, rushing to get this stuff online because it's an arms race in many
Mhm.
ways right now.
Mhm.
Whoever has the best model gets the most users, gets, data, retrains the model that you get an advantage. Like it's like the Tesla advantage on FSD. So they
Yep.
get more data, right?
I'm sorry if this is a really stupid question, but what is SF?
Full
FSD.
self-driving. So full self-driving, but they get all the data feedback from all the miles driven by Tesla drivers, and then I think Tesla will be one of the biggest users of NVIDIA or that type of gear, training an FSD model. And so they'll take all those data points, but they can get better and better and better because they have more cars on the road getting those data points. And so it's something similar with the AI models, right? The more you gather, the more users you get. And so it's this arms race to get the model to market. So you want a lot of H100 capacity, which is how you get there. It's not programmers, but you have a rush to put this online. You're going to need a lot over 24 months. You're going to need a huge amount over 6 years, over 10 years. If this, and I strongly believe that this is kind of the next wave in technology, you're going to need a lot of compute and a lot of data center power. And you're competing with the electrification of vehicles. We talked about, hydrogen, on green hydrogen. It requires a huge amount of electricity to generate the hydrogen. And so you have to figure out, where to go, how to procure the power, and you need to be somewhat creative in how you do that. And we do that really well as a company. You do have some things that help you. Like we have some things that help us in this industry, which is non-latency. It's the fact that it's not latency sensitive, right? Some of the applications here, you can go to more unique locations for data center capacity, but there's a huge competition in the market right now for power. One of the largest power providers in the US, we speak with them, we speak with everyone. We have, like I said, a great power team that finds power. Back in October, when we were speaking with them, they said that they had in the last 8 weeks, something like 12 requests for between 500 megawatts and a gigawatt of power for data center applications in the last 8 weeks. That's a massive
Yeah,
number.
that's a huge leap. Just before we move too far from a point you made a couple of minutes ago, which is that you observed a lot of people think that AI is simply like software 3.0. It's so much more than that. I was recently listening to the 2024 predictions by Clem DeLange, I hope I'm pronouncing that right, who's the co-founder and CEO of Hugging Face. And one of his points was that there's a lot of entrants to competing in this kind of arms race that you just referred to. But the prediction for 2024 is a lot of them are going to absolutely fail to get to profitability, which probably doesn't surprise you. Can you talk a little bit more about like what proportion of that kind of P&L is related to this energy usage and the infrastructure that maybe someone in their bedroom kind of like building a little app may not have accounted for, resulting in that profitability game being a little bit trickier than anticipated?
It's a huge cost for the Gen.AI companies. It's the number one cost, right? The compute is by far the number one cost. Just to put in perspective, if you come to us and I feel like we're a low cost provider on our cloud service, then you want 1,000. They actually go in multiples of 8 because of the server configuration. So we deploy clusters that have 1,024 H100 GPUs in them. Now you can break that down into like 256, 512, but generally people will want in that range if you're doing a language model training or you're training your own model on top of an open source model, depending on your speed to market, you're going to want that type of training. And so a cluster from us of 1024 GPUs on an annual basis will cost you about $20 million. We have customers that, there's demand up to, 10,000 plus of these. And we have a lot of customers that have kind of the 1 to 5,000 type deployment demands. They want them all in the same cluster, by the way, because they're much more efficient that way. That's kind of the cost of what you would think if you need, 1,024 GPUs, it's going to cost you $20 million a year. If you're doing model training, that's kind of the scale that you need to get to, I think, to compete effectively in the market. So it is a big expense. Now, the one thing that is good on the flip side is, as I mentioned, for a lot of the customers that we have, you're not paying a lot of expensive software developers to develop software for you, right? So a software dev might fully loaded cost you a couple of $100,000 a year. You can outsource that, to lower cost.
At least.
You can outsource that to lower cost locations, but you could be hit and miss on what you get out of that. So you are replacing kind of one cost for another. The issue right now, and I think this will get better over time, is I think the training side is okay for that, right? Where think of training as your research and development, line item. And so training, similar to older software companies, they would pay a lot of money to develop that software. And so you're paying maybe something similar on the training side. Now, the issue more so is when you move into, let's call it production, right? And in production where you're using inference,
Yep.
inference is still very expensive as well right now. I think inference will get cheaper over time, but that's the big.
Can I ask what would account for it getting cheaper over
I
time?
think there's going to be a lot of inference solutions in the market, right? I don't know that in many cases that it uses, especially if you're doing like LLMs, right, on the large language models, I think you'll be easier or you'll get, lower cost solutions on the inferencing side. Now, when you're thinking of video or image gen, like you're probably going to stick with pretty high cost, but people will pay for that. Software coding is probably going to stick with higher costs on the inference side. But if you're going back to on the software coding side, for example, you did your R&D to produce the Copilot that helps on software, like the GitHub Copilot. But then someone else is using that Copilot, even though they're using inference, they're using it for their own R&D. So it's another kind of R&D stack. And then image gen is similar, right? Even though you spend a lot of money to make your image model or your video model, the people who are using that are making something that they'll either be able to use many times or resell or whatever it might be. So I think that's fine. But I do think inference costs will come down, especially like on the LLM side over time, because it's hard. It would be hard as an LLM company. Right now, inference is about 20 or
Yeah.
25% cheaper than doing training, just because you don't need the same type of gear from a networking perspective. But I think that cost needs to come down because just think about your LLM goes into production, and if your cost is the same as your development cost ongoing, it's going to be really hard to make a business model out of that. So I do think the inference side will come down, but for people getting into it, it is expensive on the development side from getting GPU capacity. It is expensive. However, you're replacing a lot of people you would have normally had to hire, and you're probably going to get a much more predictable
Got
result out of it using the compute versus software devs.
This kind of leads me to a question about customer personas. Based on our previous conversation, it sounds like there was a really clear early wave, maybe some of those first customers that you worked with, like Character AI, that understood the need for this infrastructure. They moved early to invest and set it up. And then there's maybe like the more like mainstream type of customers. These are maybe big tech companies, and maybe some late adopters. Do you have a perspective on like what are the personas of these three categories? Where are we today? Like, are we still in the early wave of companies like building up and investing in this early infrastructure? Or has this been happening for a while behind the scenes? And what kind of maybe like companies or organizations should be thinking about this already? And like what kind would you maybe advise should start budgeting for it maybe 5 to 10 years out? Like, do you have a general perspective on that?
Let me talk a little bit about how we've seen the market develop. So it's, the market, I like to refer to it as been a barbell type of market, right? And the barbell is two big pieces and then nothing in the middle. And so it's been a little bit of what I refer to as the barbell, which is it's been hyperscalers, really. So everyone knows that, Meta's been big in this, Google's been big, Microsoft's been big, mostly through OpenAI. Amazon's in there, Apple's getting in the mix now. You hit the hyperscalers for the most part, the five that most people refer to. So you've had that group, which has been pretty early in the market. And then you've had the Gen.AI startups, the generative AI startups. And so OpenAI, obviously, the most prominent of that. And then you have, our customers in Character, which is a language model. They have a very cool app that you can pull from the App Store and check out. And then, you've heard names like Anthropic and you've heard names like Midjourney, which is image generators. You've heard names like Runway, which is video. And there's a big group of these Gen AI startups I call foundational models. Adept is a software model. And so you have all of these Gen AI startups, and then on the other side, you have the hyperscalers. And so those have been the two that have been super active in the market. And we've found most of our customers on our cloud service in the Gen AI startups. And now what I'm seeing come into the market is what I call enterprise. So this is companies that have their own business, and the enterprise market is going to be a massive part of this market. So it's been exciting to see that start up. And this can range anywhere from software companies or services companies or consumer products companies. Could end up, there's going to be at some point, airlines will be in this, hotels will be in this. And you just think of all the applications that they're going to have. But what we're seeing are those types of companies more on the software side right now, because I think all the software companies have been thinking about, what is their AI strategy going to be for their customers, right? They need to offer a product for their customers, whether that's a co-pilot or something along those lines. And so we're starting to see them come into the market, not just trying to figure out what they're doing, but clearly they've been trying to figure out what they're doing, but now they're coming into the market to get large amounts of GPU compute, and that's where we're running into them. So that's pretty exciting to see that start to come into the market, and that's going to be a massive part. But the things I was, talking about, if you're a consumer-facing company, you need to start thinking about your your help desk, right? It needs to be a Gen.AI chatbot. That's going to be a really easy one. And there's companies out there that are already, doing white label chatbots for other companies. But I think you're going to see a lot of growth there. If you're an enterprise facing customer, you're still going to need that. Even inside your own organization, you think about, when I just stick on the kind of the chatbot help desk, maybe an IT help desk that is an AI IT help desk inside of large companies, or maybe an IT help desk for outsourced IT, right? If you're dealing with small companies. And then every big first group that was on this inside of every organization has been marketing, right? Marketing was right on top of ChatGPT. Like you talk to anyone, really, maybe not anyone, but most people who do marketing, this has been an absolute fantastic new tool for them for creating marketing materials. You're going to want to take, for larger enterprises, you're going to want to take some of that in-house. There's a lot of companies that have restricted their employees from access to ChatGPT because they don't want company info going into ChatGPT. So they're going to train their own LLM that they'll license from, one of the large LLM providers, one of the foundational model providers. They'll train their own data into it. But these are the type of companies that I'm excited to see start to come into the market because they're established, they have a business, they make money, because there is going to be pretty significant graveyard at some point. The startups, just like every time we've ran through that, in any new cycle of any new technology, there always ends up being, some super, super successful companies, some moderately successful companies, and then, a graveyard of the rest.
Can you talk us a little bit through the differences between purchasing a cluster directly from Applied Digital and your Supercompute-as-a-Service? Like, what kind of service is appropriate for what type of use
Yeah, so
cases?
that's great, a great question. There's several different ways for people to go about this. Do they want to own their own compute? So do you want to go procure the GPUs? You want to, design the deployment, design your cluster, get all the pieces appropriate that you need for that, then go procure data center space and put that up. And now there's a lot of people who are going to do that, a lot of companies that are going to do that. Or
And would that be the barbell kind of
it
ends
could be,
that
but on the
mostly
Gen
do
AI
that?
startup guys, they've been using us on I wouldn't say an on-demand service, but a cloud service. And then on the hyperscale side, they've been building it all themselves. The enterprise, that'll be a mix. It'll be a mix of cloud like we offer, or private cloud is really one of the big things that we offer. And then there will be on-prem that they'll have as well. I'm sure of that. And so there's going to be a mix. But if you want to go and procure your own hardware and run it and keep it the maintenance and operate it, you can do that. But for smaller users, you're going to be better off using a service like ours, which is a turnkey service. Right now, most of our service is dedicated, right? So we get a large contract of someone who reserves all the capacity on those GPUs for 24 hours a day, 365, typically for a 2-year contract. We do have an on-demand solution. We do that with partners. So you just pay by the hour that you use. And so for smaller companies, that's absolutely the way for them to go. Now it's more expensive. If you see your needs growing, you're going to want to move into still a provider like us, but use a reserve contract that gets a discount because it's a guarantee. So you're going to see the mix of this, all different flavors. But the vast majority of people, if you're listening to this podcast and looking at doing something yourself, even if you're in a medium-sized organization, you're going to start with some on-demand. We offer that, AWS offers that, Azure offers that, Lambda Labs offers that. So that's part of the market. And then if you see your compute needs growing, you're going to have to move to either the reserve compute model, which is also with us, or procuring your own hardware and data center space.
And again, I am a layman, so sorry if this is a silly question, but when you say procure your own hardware, does that mean they're basically leasing or even owning a piece of the data center? What does that
You're going to
exactly mean?
purchase servers typically from someone like HP or Dell or Supermicro. They're going to put in the NVIDIA cards in there.
Oh, like literally build
Yep,
your own actual
build your own
infrastructure.
infrastructure.
Sorry, I
Yep.
understand. Thank you for kind of like breaking down the on-demand versus reserve demand definitions. Are there some common mistakes or gaps that you've been encountering, maybe particularly in the last 6 months, when companies are exploring this? And if so, do you have any advice that companies should maybe be thinking about in their exploration of what the right choice is for them?
I think for, gaining access to compute has been a gating factor for a lot of companies that we deal with. For customers that are looking, or companies that are looking, the pitfalls that we have seen is just access to compute. It's specific. I don't have a view of every problem that companies have, right? It's generally the ones that we're
Mhm.
solving. So access to compute has been kind of the biggest one that we have seen over the last, 9 months that we've really been doing this. I think for a lot of companies knowing, and I'm not just trying to plug our business, but knowing that we are here and there's other smaller vendors out there that are there, and it doesn't just have to be AWS or Azure, and to get access to the compute. But I would highly recommend using, even if it is the cloud providers, the architecture of these clusters and running this equipment is very difficult. So people trying to go at it, like they medium-sized enterprise that has managed their own IT
Mhm.
before, this is different. It's a very different set of hardware, very different set of requirements, and then would highly
Mhm.
recommend as you move into this to use a provider like ourselves or even one of the hyperscalers, because it's just different. And you'll find out with very expensive equipment that it's hard to manage.
On that note, can you share a little bit more about how could customers connect and find companies like yourselves, whether specifically Applied Digital? Like I personally never come across your company
Yes.
before we had, our first connection. Where do you look? How do you
The
connect?
Google search works. It doesn't, you won't find us if you're looking for GPU compute. And the reason is until recently, we've never had a single salesperson inside the company. We hired our first back in November.
Can you share why? Is there a reason that was the case?
So we haven't needed it. Almost since inception of the company, we've had more demand than had supply of what we provide. That still remains the case to this day by a fairly wide margin. The reason we added a salesperson is because
Mhm.
I started to see this enterprise market develop, and we want to go really aggressively after that enterprise market. And I think having us out there and marketing ourselves finally, this is the appropriate time. But you won't see us. We don't advertise on Google. All of our capacity is generally spoken for, but you can Google. You'll find some of these other providers, like I said, like a Lambda Labs or a CoreWeave, that are the ones that I would count as competitors to us on the cloud side. And then you'll run across AWS or Azure. But if you
Mhm.
Google, you will find some of the smaller providers out there.
Okay, got it. Just for the last few minutes, are there any kind of like predictions or final words of advice that you would like to end
My
on?
biggest prediction for 24 is that just going back to data center space, and people don't think about it. No one ever thinks about it, right? I know, like, I have kids, and a lot of people that I interact with, they, have no idea how things show up on their phone, right? It just does. So, everything that you use, there's the
Interesting.
data center somewhere nearby running the compute workload for you. But data center space,
Mhm.
which is, historically a very pretty boring market, is going to be the bottleneck for AI deployments this year. I think there was a big bottleneck in NVIDIA GPU deployments
Mhm.
last year, and that it's still tight in that market, and especially on the InfiniBand portion of it. But the data center capacity to turn those on, and just leave it like this. So fixing additional wafer throughput or a more advanced packaging capacity, which were the bottlenecks, high bandwidth memory. These were the bottlenecks on the equipment shipments last year from NVIDIA. So fixing those, to me, is much easier than finding a large amount of power, securing that power, getting delivery of that power, getting permits
Mhm.
to building large buildings that are fairly complex. That's just going to take a longer amount of time than fixing, the supply chain issues on GPUs. And so I think as we get into
Mm.
24, I think we're already starting to see that issue, but I think that's going to start to
Yeah.
pop up more and more and more as a primary issue on the deployments of compute for AI. And then I think you'll start to see a lot of articles around, the power consumption of AI, right? You've probably seen some of that already, but you're going to see a lot of that in 24, because, that's really going to start to ramp up in 24 and 25. And so for us, all three of our sites were co-located with wind
Mhm.
farms. We find stranded power generally off of renewable sources, primarily all of them right now wind.
And stranded power just means that it's power that can be deployed to any city or village or
There's
town.
not the infrastructure in place to carry that power from where it's generated to an end use. And so these exist, right? And a lot of
Mhm.
it exists in the US either because a business went out of business, right? There've been locations where, for example, there was a big aluminum smelting facility that went out of business. And so there was a big power infrastructure there for that. And
Mm.
now it can't be sent anywhere else. But for us, it's all been renewable, deployments, renewable developments primarily in North Dakota, the sixth largest wind state in the nation and the 49th largest population state, I believe, are the numbers. They produce over double the amount of power they consume in the state. And a lot of that can't be transported out. And so In a lot of instances, when the wind is blowing and the power usage is low, wind farms get curtailed. So because it runs too negative on the grid. And so we kind of come in and balance that out and find that power. But you're going to start to see more and more talk about, the power consumption of data centers. I mean, that's been a big issue, for a while already, but it's going to become a very growing issue. But I think my number one prediction is just, I think people will be surprised that data centers become the gating factor of deployments of compute for AI.
Great. Wes, thank you so much for joining us and sharing your expertise and your perspective, as well as for your predictions. And I wish you a wonderful day, and hopefully we'll chat again
Yeah,
sometime
Tina,
soon.
thanks for having me. I really appreciate it.
Thanks for listening. If you've gained value from this episode, please drop us a 5-star rating on Spotify or a like on YouTube. See you for the next one.